Hello, everyone. This is the assignments that we have to complete this week. So the first assignment, it's on the roof, and the second, it's on the ventilation. We can have two kind of sorry, the first one is on the floors, and the second one on the ventilation. We can have two kind of floors in a residential building. We can have a floor that it's over a crawl space. A crawl space, it's something that has like 3 feet and it's usually ventilated. Okay, so it's a cavity that we have underneath, and here we get rid of the, well, we have the drainage and we have the different elements that we don't want to see in our house, and we have it underneath our house. The assumption that we made is that the temperature in this air chamber is the same as the outdoor temperature. If it's ventilated enough, this is a good assumption, and we will be losing some heat through the floor. And it's important that the thermal insulation is at this side of the floor so that we don't have any thermal breach, and we have a continuous thermal insulation. So this is what I would do if we had a crawl space. How can we calculate that with the Excel file? On the Excel file, we can copy this, okay? And this is floor 1, and it depends on the detail that we can have in that floor. The floor detail can be very similar to the roof detail. You see that we have some elements, joists, structural wooden elements, and then there's a gap between two joists, and we can fill this with thermal insulation. That's what we are doing. And then we have the flooring, the floor material. But again, we will have this part with the joist and another part with the thermal insulation. So we need the U average of this floor. I'm going to do it again. So if this is floor 1, we don't have air exterior. We have to change this because in the floor, the top air is interior and the bottom air is exterior. So that's why we changed that. And then here we have the flooring system. We can have the flooring material. It can be concrete or it can be, when we're talking about floor, we're talking about hardwood, can be oak. When we're talking about the rafter, well, in this case, we have this word joist. It's the joist is a rafter. So for roofs, we have rafters. For walls, we have studs. For floors, we have joists. Well, it's a structural wooden element. And if this is the joist, this is softwood. So it can be pine. That's the difference between the, it can be red or white pine. And then here, the gypsum board, it's not gypsum because it's on the crawl space. Okay, so that material is the polyisocyanurate. So it's a complicated name. Polyisocyanurate. Yeah, so that's the why. That's the material, and it's waterproof. So if it's in contact with the soil or can be in contact with the soil, this is the material that we have to use. What we need to know now is the thermal, so it's this kind of board. It's the thermal conductivity of that material. So I'm going to Google thermal conductivity because I want to create a new material on my table. If this is the thermal, it's between 0.022 and 0.035. And be careful with the units. This is watt meter Kelvin. We have to convert this into, so we have to convert watts divided by meter Kelvin to BTU inch divided by square feet Fahrenheit hour. So that's the conversion. And I'm sure that we can have here different websites to convert this. Okay, so this is watt meter Kelvin, and we have to convert this to BTU inch hour square foot Fahrenheit. If this was from 0.02 to 0.03, okay, so it's something similar to 0.025. If we convert, this is 0.17. So that's the thermal conductivity of that polyisocyanates. If we go to this table, we have to insert a new layer here. It's polyiso something. Let's do it with alphabetical order. Let's insert, and that will be polyisocyanates. And this was 0.17. Okay, the good thing of working with this table is that if I go to this floor, this is not the gypsum board anymore. This is the polyiso cyanurate, this one, and that's the thermal conductivity. So at least we have these three. We have the structure, we have the flooring, and then we have something, we have the board to protect this wooden structure from moisture or humidity. So those are the three materials that we can have there. Here we have the timber red pine. We need another element. We need another table. And this table is through the thermal insulation. And we don't have timber. We can have any thermal insulation. Let's say rock wool insulation. That changes. And here we have 26, the thermal resistance. The thermal resistance here is 48, the U value. But in this case, we don't have all this information here because we need to calculate the U average. Okay, so when we have two different materials, we have to calculate the U average, and the area is the total area of the floor. We don't have the area of the rafters or the area of this. We have the total area of the floor. We need a dimension for this width. This width, if we go to that detail, again, we can say that the width of this rafter is 2 inches and the space between rafters is 14. We can type here 2, and we can type here 14. And what is that U average? It's the same formula we used for the roofs. I have to type equals, 2 parentheses. It's this thermal conductivity, thermal transmittance conductivity, this U value, times 2, because that's the width of the rafter. I have to close the parentheses, plus this thermal transmittance times 14, and I close the parentheses. I close the parentheses again, and now I have to divide all these by open parentheses, this plus this. And now that's the U average. If I format cells and I use number 3 decimal places, we see that this value has to be somewhere between 0.017 and 0.38. This is 0.02. It's between these two values, so it seems correct. Here is where I have to place the total area of the floor, let's say 300 feet. That's the UA value. So this is very easy because this is just this value times this one. And that's the UA value. I want to copy the format here because I want only 2 decimal places. Like this. And finally, this is the thermal load. Okay, so the thermal load equals the UA value, this, times indoor minus outdoor temperature. And again, format cells, 2 decimal places. What are the units of this? Units are important. It's BTU hour. Don't forget that this is BTU hour, the units of this thermal load. So that would be the U average we are looking for. And that's the total thermal load. This, if we have this detail, if we have a single family house with no basement, this is the table that we have to use. What if we have another detail? We have a single family house with a basement. Okay, so if we have a single family house with a basement, we explained why we have to divide the basement into the basement wall into slices of 1 foot. We don't have any thermal losses through the floor if we have a thermal insulation, because the path between the indoor air here and the outdoors, it's quite difficult. So we can assume that we don't have any heating load through the floor, but we have heat losses through this wall. The most important heat loss is the one that it's closest to the outdoor air. And as we are going down, we have less heat losses. How can we do this? Well, the ARCH260 is giving us this table. What I'm going to do is to copy this table into my Excel file, to copy it here. And I'm going to change the format. Looks better. And well, I told you that we have to delete in this table that the ARCH260 gives us. I'm going to delete these dark gray values. So I'm going to delete this column. I'm going to delete this column. And then I'm going to delete this column. It's the columns in which we have this S here at the beginning. So delete. And I'm going to make it bigger. So you see we have, this is the path length. We don't have to change that. And here we have the uninsulated, the R, and different thermal insulating values here. So I'm going to use this as the uninsulated. And here we have 7 feet, 0 to 1, 2, 3, 4, 5, 6, 7. If we have more, we have to build a bigger table with more rows. In our assignment, what we have is, it's a 7 foot below grade basement wall. And the R value is 9 only on the top 1 foot of the wall below grade. So what does it mean? It means that we have thermal insulation. Here we have thermal insulation 3 feet. In our case, we only have thermal insulation this 1 foot. Okay. And what does it mean in the table? The wall, if the R value is 9, the R value of the thermal of the wall is 9 when we have thermal insulation, then we have to select the next closest or lowest value. If we have 12 and we have 8, we have to select this column, and we have to select this column on the first foot. So I'm going to highlight this. This is the one with the thermal insulation. And then the rest of the wall is uninsulated. So I'm going to use this blue color, okay, because this is where the thermal insulation is, and this is where the rest of the wall, it doesn't have any thermal insulation. And the value that I need here is the perimeter of the basement. What's the perimeter of the basement? It's if you have a rectangle, so it's this dimension plus this, plus this, plus that. So imagine that this is 50, it's 90, okay? So in this example, the perimeter is 90. It would be different in the building that you are working with. And here, what we need to do, because what we have in this column is the heat loss coefficient. So that's the U value. But now we need the U value times the perimeter, and then we have to add everything up. So we have the U value of the first foot times the perimeter, plus the U value of this foot times the perimeter, so on and so forth. So here we have UA. UA is on the first foot, that equals the first U value, 0.09, times the perimeter. And if I want to drag this down, well, I don't have to drag this down. So that's the first U value. The second foot is this value on the second foot times the perimeter. And now if I drag this down, I don't have valid values here. Why? Because if I want to refer to this perimeter, I need to type the dollar letter and dollar number. And then if I drag this down, I have it here. Okay, so that's the U value. The first one is the first foot times the perimeter. The second one is the second foot times the perimeter. The third one is the third foot times the perimeter. And the last one is the last foot times the perimeter. And what is the total thermal load? I'm going to place it here in this, because here is where we have the thermal loads in BTU hours. So I'm going to copy the units here, BTU hours. So that's the total U value, the total UA value, because I have to add all these up, times indoor minus outdoor temperature. So how can I write this formula? So on that cell, first I need to insert function, and this function is sum. And then I have to select the range. So I select all these UA values. So I have added up all these, but that's not enough, because I have to multiply these times indoor minus outdoor temperature. So I need to use another parenthesis here, and I have to multiply this times the indoor minus the outdoor temperature. And that's the total U value of this, or the total thermal load of this option, of the basement. Okay. So when we have a basement, I can merge and center. And this is the basement. If we have another basement, I can copy this. So we can have a building in which we have part of the building that it's on the crawl space, and another part of the building that it's on a basement. Okay, if that's the case, in these floors, I need two tables. I have this thermal load through the first floor and this thermal load through the basement. If I only have a crawl space and I don't have a basement, I can type here 0, and I don't have any thermal load through the basement because I don't have a basement. Or If I do have a basement and I don't have any floor on a crawl space, I can type in this area 0, and then I only have the thermal load through the basement. At the end, I can have a total thermal load. If I want to use this cell, what's that total thermal load? It's the sum of this value plus this value. Okay, so if I don't have any floor on the crawl space, my area is 0, and this value is 0. If I have a floor of 300 square feet, now I have a value here, I have a value there, and this is the total. If I don't have a basement, I just type 0 on the perimeter of the basement, and I have only the area of the thermal load. Okay. In this case, in the assignment, we don't have a crawl space, so that's 0, but we do have a basement. So you need these two options. We have a floor over the crawl space if we have joists and thermal insulation. We need this. If we have a basement, then we have that. And then depending if we don't have this, I type 0 in this area. If I don't have a basement, I type 0 on the perimeter, and we have this value. What do you have to do on the assignment? You have to consider this basement. So you only have to, if we have a basement, we don't have a crawl space. So that will be the perimeter of your basement. This plus this plus this plus that. You have to type that perimeter based on your numbers. And you have to change the indoor and outdoor temperature, 72 and 20. But you have to do what we have done on this video. And select another slide and copy and paste this. Okay, so that's the basement. I have to make sure that you have selected this with thermal insulation R9 on the first foot, and then uninsulated walls on this, and that's the total thermal load.